Everyone, this will be a set of review problems for you to look at. The only kind of problems that we're not going to be looking at that are going to be included on your test will be problems like the write and solve rational functions worksheets 1 and 2, which I have, the previous two videos are over those worksheets, so you can always go back and check those out and rework through those problems as well, as you won't be given any word problems for your review. So you can also get this set of problems on the video calendar along with the answer key if you wanted to print it out, or you can sit through this and work through it with me, but you just want to let you know there are resources on the video calendar as well. Okay, so let's go ahead and get started. On number 1, we are told to simplify and state where the expression is undefined. So you have 10 over 6, well that reduces to 5 over 3. And x to the 8 divided by x to the 4th. When dividing like bases, subtract the exponents, so we have x to the 4th. To state where it's undefined, x cannot be equal to, well, we look at that denominator and we figure out if, I'm trying to figure out what x value will make that equal to 0. And so if I solve for that, that would be x is 0. So it's undefined for x equals 0, and there's the answer to number 1. Number 2, we're also going to simplify this, but notice that we have addition and subtraction here. Do not cancel out the x squared and the x's. You cannot cancel out parts if things are not factored. In number 1, we just had factors because there was multiplication. But whenever you have addition and subtraction signs, you cannot cancel out anything until everything has been factored. So in this top thing, that will factor into x plus 3 and x minus 1. And the denominator will factor into x plus 6 and x minus 1. So now we can see whatever matches on the top completely with something that's on the bottom will cancel. So we have x minus 1's cancel out. So then we're left with the x plus 3 over the x plus 6. To figure out where it's undefined, go back in time a little bit before we cancel things out and look at what x values would make this denominator 0. So if I had a negative 6 and I had negative 6 plus 6 would be 0. So it cannot include negative 6. And then we had what minus 1 would give me 0, and that's 1. So it's undefined at negative 6 and 1. Okay, on number 3, again, factor everything completely before canceling things out. So I have a greatest common factor of 6x in the numerator. And when I take that out, I'll have x squared plus 1. And my denominator cannot be factored anymore, so it will stay together, x squared plus 1. Now I can see that the x squared plus 1's cancel, so I'm left with 6x. Now to figure out where this is undefined, I'll have x squared plus 1 equal to 0. And whenever I solve, I'll get x squared equals negative 1, but when I take that square root, I'd be taking the square root of a negative. Well, that's not a real thing. So if you end up with x equals an imaginary solution, then it will be always defined. And that should make sense because no matter what my x value is, whether it's positive or negative, when it gets squared it'll be positive and then plus 1. So this denominator will never be equal to 0 for any x value that we would plug in as far as real numbers go. And then number 4, again, let's factor everything completely. So this has a greatest common factor of negative 2x. And when I take that out, I'm left with 2x plus 5. In the denominator, that's a difference of 2 squares, so I'll have 2x minus 5 and 2x plus 5. Now that everything is factored, cancel out anything that matches, so those two things cancel, and we're left with negative 2x over 2x minus 5. Those 2x's do not cancel because this 2x minus 5 is just all one piece. And then to figure out where it's undefined, I would look at what x values would make this denominator 0. And so if I set either one of these factors equal to 0 and solve, I'll end up one of them with positive and one of them with negative 5/2. Alright, so that's simplifying. Let's look at multiplying and dividing. Okay, so on number 5, before we multiply anything together, let's factor everything completely. So on this first expression, that has the greatest common factor of 2, so that'll be 2 times x plus 7. And its denominator is a difference of squares, so that'd be x plus 5 and x minus 5. Then we'll have times. The 8x plus 40 has the greatest common factor of 8, so then I'll take that out and I'll have x plus 5. Over, my denominator has the greatest common factor of 6, so I take that out and I'll have x plus 7. Alright, so whenever I multiply fractions, I multiply straight across, so really this will just become one big expression. So I can start canceling things out now. The x plus 7s will cancel. The x plus 5s will cancel. And then 8 times 2 is 16. Then divided by 6, that would reduce to 8 over 3. You could also say 2 over 6, the 2 will go away and this 6 will become 3. So you'd have 8 over 3. That's another way of looking at it. And then we'd have 8 over 3 and the x minus 5. And this said that we didn't have to worry about where it was undefined, so we don't have to look at that part. But we'll just have that 8 on the top. Okay, looking at the next example. Alright, so I've got multiplication and division. I'm just going to go ahead and flip this second thing. Remember, if you have division, you can take that second thing and flip it upside down and make it multiplication. So I have 8x cubed over 2xy. We'd still have that times y to the 4th over 6x squared. But then this y squared over 3x to the 4th, if I change this to multiplication, I'll have 3x to the 4th over y squared. More than welcome to cancel things out, but I'm afraid that I may lose track of everything, so I'm just going to multiply everything straight across into one big fraction. So then I'll have 8 times 3 is 24. X cubed times x to the 4th is x to the 7th. And I've got y to the 4th over 2 times 6 is 12. Y times y squared is y cubed. Oops. Let's not go in out of order. X times x squared is x cubed. And then y times y squared is y cubed. Now I can reduce this. So 24 divided by 12 is 2. X to the 7th divided by x cubed. When dividing like bases, subtract the exponent. So we'll have x to the 4th. And y to the 4th divided by y cubed is y. And there's your answer. Alright, the next example, so y to the 5th, x to the 5th y cubed over 6xy squared divided by the second expression. Let's go ahead and make this multiplication. So the first thing will stay. Let's make this multiplication and we'll flip this upside down. So we have 2x cubed y over 2. Okay, so again, if you wanted to, you can make this into one big fraction. Multiply everything straight across. So I'd have 2x cubed times x to the 5th is x to the 8th. And y cubed times y is y to the 4th. Over 6 times 2 is 12. Then we'll have x and then y squared. So to reduce this, 2 over 12 reduces to 1 over 6. So there'll be a 6 on the bottom. And then x to the 8th divided by x, so 8 minus 1 is 7, so I'll have x to the 7th. Y to the 4th divided by y squared, subtract 4 minus 2 is 2. So there's our simplified expression. Number 8. Okay, so again we have division, so we're going to flip this into multiplication, but we're also going to factor this completely as we go. So on this first thing, I don't have to worry about factoring anything. There's only multiplication. So it stays the same. We'll have 8x to the 4th over 4x to the 6th y times, okay, so I'm going to flip this second thing upside down, but I'm going to factor it. So what does this denominator factor into? And that will be x minus 4 and x plus 3 over the y plus 3y has the greatest common factor of y, and so then when I take that out, I'll also have x plus 3. So now we can cancel out the like terms. So the x plus 3's go away. And then, let's see, everything else looks like it'll stay, so we just need to simplify. So 8 over 4, 8 divided by 4 is 2. And x to the 4th divided by x to the 6th. When dividing like bases, subtract. So 4 minus 6 is negative 2. So whenever you end up with a negative difference, you'll move it to the other side to make it positive. So I'm going to put it back down here. And then the x minus 4 stays on the top. And then y times y is y squared. All right, let's look at one more of these. All right, so this time we are going to be, well, maybe this one's in a weird spot. It should have multiply or divide. I should have said or add. But I have 5x minus 1 over x plus 3 plus 3x over 2x plus 6. I need a common denominator. If I look at this denominator right here, that's the same thing as 2 times x plus 3. Well, it's really close to this other denominator, but it has a 2 in there, so I need to multiply this other thing by 2 on the top and the bottom. So, don't forget to distribute that across the whole thing. So that will be 10x minus 2 over, we'll leave the denominator factor, there's no need to multiply it out, plus 3x over 2 times still that x plus 3. And now I can add my numerators together. So 10x plus 3x is 13x, and then we have minus 2 over, still there's the 2 times the x plus 3. All right, let's look at some more addition and subtraction problems. All right, so I've got 3 over x minus 2 minus 4 times x squared minus 7x plus 10. All right, so I'm always going to start out by factoring my denominators. So this is x minus 5 and x minus 2. Well, this one has an x minus 2, but it doesn't have the x minus 5. So I'm going to multiply this one top and bottom by x minus 5. So that way the denominators are the same. So I will have 3 times x and 3 times the negative 5, so minus 15, over x minus 5 and x minus 2. And I'm going to go ahead and change this plus to a minus right there. So I'll have plus a negative 4 over x minus 5, x minus 2. I changed the sign right there. It didn't really matter on this problem, but I always like to distribute the negative so that way I don't forget that I was subtracting something. And combine like terms, so we'll get 3x, negative 15 plus a negative 4, is a negative 19. Then the denominator is just x minus 5 and x minus 2. Okay, so number 11. Again, I'm going to start out by factoring. So all of my denominators. So this first one factors into x plus 2 and x minus 1. The second one factors into x minus 4 and x plus 2. Well, before I can add these things together, I need a common denominator. So if I take this first one, so they both have an x plus 2, but one has an x minus 1, the other one has an x minus 4. So they each need everything. So this one will need an x minus 4. So I'll multiply both the top and the bottom by x minus 4 on this side. And over here, this one needs the x minus 1. So I'll put the x minus 1 and the x minus 1 on the top and the bottom. So now I'll multiply the numerators out. So I'll get 3x squared minus 12x over all of this craziness of our common denominator now. X minus 4, x plus 2, x minus 1. Then plus 5 times x minus 1, so we'll have 5x minus 1 over the same thing. And then all I need to do is add the numerators. So I'll have 3x squared, negative 12x plus 5x is negative 7x, and then minus, oh, did anyone catch that? 5x times a negative 1, that would be minus 5. Oops, okay. So then minus 5. And again, over that same denominator, and I have run out of room. And then number 12, x over 2x plus 3 minus 4x plus 5 over 2x minus 3. So these are not exactly the same. It may be tempting to see that those are the same thing and just subtract, but you can't do that. So I will have to multiply each by the other. So I'll take 2x plus 3 on the top and the bottom. And this one will get the 2x minus 3. So when I multiply this numerator out, I'll have 2x squared minus 3x over, I'll leave the denominator factored, and let's see, you have two choices here. You could distribute the negative now, or you can multiply it and then distribute it. Either way, you'll end up with the same numbers. But I'll have minus 8x squared plus 22x plus 15 over that 2x minus 3, 2x plus 3. So I have 2x squared minus 8x squared. I'll get negative 6x squared. A negative 3x minus a 22x is a negative 25x. And a negative 15. And again, that denominator. Okay, so the rest of the problems we will be solving equations and inequalities. Okay, so because these problems are going to take up a lot of space, for each of these, I'm just going to block off the rest of these equations and use this whole white space, then we'll erase, and then I'll do the next problem. Okay, so on this first one, well, this one may not take as much space. But anyways, we're going to solve each equation or inequality here. And you can see that I've got x plus 1 in these two denominators, but I can't forget the fact that this is a 2 over 1. And so I want to get rid of all these denominators at once. And one way I can do that is to multiply each part by my least common denominator. So I'm just going to write that above here. So I'll have x plus 1, and x plus 1. Really, I'm multiplying my numerators by this thing. So if my numerator now has an x plus 1 and so does my denominator, they'll cancel out. The x plus 1s will cancel out here, but I'll have to take that 2 and multiply it by the x plus 1. So now I'll have 3x equals 2x minus 1, and then minus the 2 times the x plus 1. So I'll have a minus 2 and the negative 2 times 1. I'm sorry, minus 2x. So then that'll be then a minus 2. If I collect these like terms, so I'll have, if I notice here I've got a 2x and then a minus 2x, so those things will cancel each other out. So I've got 3x equals negative 3, so then x equals negative 1. But you always have to check your solution. So if you remember, back before I canceled things out over here, my denominator had an x plus 1 in it, which means that this expression would have been undefined at x equals negative 1. In other words, if I plug that negative 1 back in here, I would have 3x over 0, or negative 3 over 0, and I cannot divide by 0. That's undefined. So that means this is not our solution. In fact, we have no solution. All right, let's look at another one. So on 14, we'll have 2x over x plus 3 minus 1 equals 8 over x squared minus 2x minus 15. Okay, so again, let's go ahead and factor this denominator so we can see what we're working with. We've got an x minus 5 and an x plus 3. Well, I have an x plus 3 here. So if I want to get rid of all of these denominators at once, I'm going to multiply each thing by my least common denominator, whoops, which will be x plus 3 and x minus 5. And don't forget about that 1. Okay, so on this first thing, the x plus 3's will cancel. So I'll be left with 2x times x minus 5, which I'll just write over here for a second. 2x times x minus 5. Then I'll have minus x plus 3 times x minus 5 because it couldn't cancel out with anything. And then on this last thing, the x plus 3 and the x minus 5 cancel, so we're just left with 8. So when I multiply this out, I'll get 2x squared minus 10x. This right here is, if I multiply that out, I'll get x squared minus 2x minus 15, but then I'll need to distribute that negative. So if we distribute the negative, then we'll get a negative x squared plus 2x plus 15 equals 8. And if I collect all my like terms and get it on one side of the equal sign, I'll end up with x squared minus 8x plus 15, plus 15 equals 8, but then whenever I subtract it over, well, let's just keep going. Subtract the 8 over. This is something that factors. So that'll make it easy to get this solution. So if I factor it, I set each factor equal to 0 and solve, I'll get x equals 7 and x equals 1. Make sure that these are not values where any expression would have been undefined. Well, it only would have been undefined for negative 3 and positive 5, and these are both acceptable. Box those answers. These are our solutions. Okay, on the next example, we have negative 3 over x plus 1 equals 10 over x plus 2. So let's just rope off this area here. So my least common denominator, I've got an x and an x squared. So my least common denominator would be x squared. So if I multiply everything by the least common denominator, and by everything I mean the numerators, and cancel out, so x squared divided by x, we'd just be left with an x. So that'd be a negative 3x. X squared times 1, so we have plus x squared. And then 10x squared over x squared will just be 10. So if I move everything over here, I'll get x squared minus 3x minus 10 equals 0. And this factors. So I'll have x minus 5 and x plus 2. So then my solutions are 5 and -2. And remember that if I were to go back and look at these, so I have a 5 and a -2. If I plugged in either one, it would not be where it's undefined, so both of these are answers. Okay, now let's look at some inequalities. At this point, I'm going to erase all of this other work so I can have blank space to write in. And these are the longer two-part problems, and so it's a really good idea for you to stick around and don't exit out of this video too soon. Okay, here we go. Okay, so we're going to start out with this number 16. We've already done 15, so we don't need to even look at that one anymore. Okay, we're looking at 16. Okay, so I've got 7x over x minus 3 is less than or equal to 0. Now remember, whenever we're solving these, yes, we are going to multiply that x minus 3 over to the other side, but we cannot forget that multiplying by a negative will switch the sign, whereas multiplying by a positive will not switch the sign. So we have to look at the two different scenarios. And the first one would be that our least common denominator is positive. In other words, that x minus 3. And then we'll have to do this again for when it is negative. Okay, so if it's positive, let's go ahead and work through this. So if I multiply both sides, so there's my 7x over x minus 3. And if I want to multiply both sides by that x minus 3, so that will cancel. Then I'll have 7x is less than or equal to 0 times anything. It's just 0. And then whenever I divide by 7, I'll get x is less than or equal to 0. But we're not done. That's just the first part. We said that it was positive, that x minus 3 is positive, so that means it's bigger than 0. So if I set that greater than 0, because it's positive, and I solve, I'll get x is greater than 3. Whenever you are looking within that positive scenario, these two things will make an and statement. So that means whenever we draw a little number line here, and is where it's overlapping. So we've got a value at 0 and we've got one at 3. So the first part would be x is less than or equal to 0. So there's the equal to part, and it would be that way. And then x is greater than 3. So greater than 3. Well, and is where it overlaps. Well, it doesn't overlap anywhere, so this part presents no solution. But let's go back and look at the negative scenario. So if we have that 7x over x minus 3 less than or equal to 0, and this time when we multiply by x minus 3 and we're pretending that it's negative, the x minus 3's cancel and we have 7x, but because we multiply by a negative, the direction of the sign switches. So then we have 7x is greater than or equal to 0. And when we divide by 7, we'll get x is greater than or equal to 0. And that's the first part. But we said it was negative, so we need to go back and take that x minus 3 and show whenever it was negative or less than 0. And so we get x is less than 3. So there's the two parts. And remember that this again is an and statement. So we need to look at the number line again. And of course we're going to have the same numbers, 0 and 3. But this time, whenever we're looking at our numbers, we have x is greater than or equal to 0. So things that direction. And x is less than 3. So open circle on the 3 and less than that. So we're going to look for where it overlaps, which will be here in the middle. So that would be 0 is less than or equal to x is less than 3. So now that we have those two parts there, between the two parts, that's an or statement. So within this scenario, the two parts are an and so we're looking at the overlap. Between both scenarios, that would be an or. So we either have no solution or this. Well, anytime we have an or statement, we want to include any solutions that were presented. So our ending statement will be the set of all x values where 0 is less than or equal to x is less than 3. We don't need to include the no solution. So there's our answer. Okay, so let's look at number 17, and this will be your last example. Okay, so on 17 we have 5 over x minus 7 is less than or equal to 2. So again, we're going to do it both ways, where once where it's positive and once where it's negative. So on the positive side, when I multiply both sides by x minus 7, I'll get 5 is less than or equal to 2x minus 14. So I'll have, whenever I add 14 to both sides, I have 19 is less than or equal to 2x. So if I divide by 2, I'll get 9.5 is less than or equal to x, but I'm going to rewrite it so that way the x is in the front. So I have x is greater than or equal to 9.5. So there's the first part. But this is where the denominator is positive, so I need to take that x minus 7 greater than 0 since this is positive, and I'll get x is greater than 7. But this is an and statement. So let's do our little number line. And we've got 7 and 9.5. So on this first part, we have x is greater than or equal to 9.5. So greater than or equal to, so it'll be above that, and x is greater than 7. Well, you want to look at where it overlaps, and that's this part right here, and that can be summarized with x is greater than or equal to 9.5. So now let's look at the negative. Whenever we multiply both sides by x minus 7, that cancels. So we have 5 is less than or equal to 2x minus 14. Again, add the 14, you'll get 19. Oops. Don't forget to switch the sign. Okay. When you multiply by a negative, you switch the sign. And then divide by 2, and again you get 9.5, but this time it's x is less than or equal to 9.5. So there's part 1, but we also need to check whenever the x minus 7 is negative. So when it's less than 0, we get x is less than 7. This is an and. So we need to summarize this by looking at our number line. And again, we've got a 7 and the 9.5. So we've got x is less than or equal to 9.5, so less than or equal to 9.5, and x is greater than 7. So x is greater than 7. Or I'm sorry, x is less than 7. Silly me, x is less than 7. Okay, so for the overlap, that's right here, and that's summarized by x is less than 7. So remember, between the two parts, it's or, so I'll need to include both things. So instead of all x is where, x is less than 7, or x is greater than or equal to 9.5. And there's your answer. Okay, that's it. Please let me know if you have questions tomorrow in class. This is all we'll be talking about. And your test is coming up soon, so I will see you then. Bye.